Alright, here's example 2 for completing the square. Converting things from standard form to vertex form. So again, this states right here, we have an equation, a relation in standard form, and it says to write the following in vertex form and in factor form. Find the vertex when in both forms. So again, just to bring up our summary from the previous example, what you want to do is we want to factor out the a value for the first two terms. So in this case, if I were to write out the standard form just above it, ax squared plus bx plus c. This is supposed to be a square value. That's a plus ci. Okay, so factor out the a value. So the a value in this case is going to be my -2. So that's a. What's going on here? So that's step 1. We're factoring out that a value. So y equals, I'm going to factor out that -2. And what we're left over with is x squared. We're dividing -8 divided by -2, which is going to be plus 4x plus 10. Now remember, a is always just a coefficient. You're actually factoring out the coefficient. So even though there's an x term that's in common from both of them, we're not common factoring the greatest common factor in this case. We're only common factoring out that a value, which is just a number, a whole number without the x. Okay, so this is kind of like a different thing for you. So please be aware of that. You're not necessarily factoring out the x's as well. So second step is to half b and square the result. So what is my b value in this case? B in this case is 4. So I'm going to write half of b, which is half of 4, and square that result. So half of 4 is 2, square it becomes 4. And that's the number that we're going to add and subtract right there. So actually, let's highlight this. Step 2 is right here, halving and squaring. Okay, and then step 3 is to get that value, which is this value, which is the 4. So we're x squared plus 4x. And what we're going to do is we're going to add and subtract that value, which is 4 minus 4, this value right here, plus 10. The next step is to distribute the last term only outside the brackets so that we have a trinomial inside here. So right now I have 4 terms, I only want 3 terms, so I'm going to multiply this -2 and that -4 out. So I'm going to use yellow to highlight. So that's this. Okay, let's go back to this pen. Y equals to -2. This stays, this stays, this stays. This is a plus 4. So we're going to multiply -2 times -4, which is going to give us plus 8. And then we have plus 10 again, which is just relaxing. So the only thing that changed is we're only doing -2 times -4. And then the last term is to factor out that perfect square trinomial. So which is this part, -2. Two numbers that multiply to +4 and add to 4 are going to be plus 2 and 2. I don't know what color to use, but I'll use blue again. Plus 2. X plus 2. And we can simplify this, which is plus 8 plus 10, which is going to be 18. And our last step is to try to convert this into, there's 2 of them multiplying each other. They're repeated, so I can say this is squared plus 18. And there we go. We can find the vertex here because it's in vertex form. The vertex is, remember to switch the sign, it's going to be -2 and this is 18. So we can extract the vertex from there. Alright, so we have to find the following in factored form as well. So I'm going to do that on the next page. So we're going to write this in factored form. So I'm going to rewrite this right here. So to write this in factored form, we get a factor, and the first type of factoring you should always check is common factoring. So is there anything in common between all three of these terms? A -2. So let's common factor at a -2, and what's left over is going to be an x squared. -8 divided by -2 will be plus 4x, and 10 divided by -2 will be minus 5. And now we do some trinomial factoring. So we find two numbers that multiply to -5 and 4, and that would be plus 5 and -1. Because 5 times -1 gives you -5, and 5 minus 1 gives you 4. And here, in order to find the vertex, again, we're going to find the x-intercepts. That's what the advantage of factored form does. So to find the x-intercepts, we set y equals 0 over here. And now that it equals 0, we can state that x equals to -5 and x equals 1. So to help us find the vertex, we're going to find the average between these two things. So the average between these two, we add them together and divide by 2. That's how you find the average of two numbers. -5 plus 1 will be -4, divided by 2 will be -2. And so now, to find the actual vertex, we can plug it back into the original. But I'm going to do something different, such that it's a little bit different for you guys. You can remember that this original standard form equation is equal to this equation as well. So I can actually plug it back into the factored form of the equation. So I'm going to call this A. So sub x equals -2 into A. And so y equals to -2, -2 plus 5. And this would be -2 minus 1. -2 plus 5 will be 3. -2 minus 1 will be -3. And we can multiply this together. 6 times -3 will be 18. And so the vertex is this x value, which is the average of the x-intercepts, and this y value, okay, which is the exact same answer that we got here, -2 and 18. -2 and 18. You can either do it with vertex form or in factored form. Okay. Now, this has a disadvantage because not all quadratics have x-intercepts. So, which is why we're teaching you this, because they might not necessarily have x-intercepts, so you can't average. Okay, remember some problems like this, you won't be able to factor it, you won't be able to find a quadratic formula for that. No x-intercepts, you're going to have to do another method. Okay, and this method is pretty general because it gives you a mapping, you can get that mapping notation and the y value of the vertex right away. Okay, that's it for example number 2.